This is Mr. Martin. These are the video notes for Honors Geometry, Section 3.4. So in this section, we're going to take one more step after getting corresponding parts congruent. So first we proved triangles congruent, and then once we had the triangles congruent, we knew the corresponding parts were congruent. And now we're going to use those corresponding parts to help us prove some other things. So before we get to that, we need to talk about a couple of new concepts. The first one is a median. So a median is a segment of a triangle. It joins the vertex of the triangle to the midpoint of the opposite side. Okay, so if I draw on a triangle here, we'll call it triangle ABC. And if I find the midpoint here, we'll call that D. So I know it's the midpoint because I can tell by the tick marks. If I connect the opposite vertex, so B, to the midpoint, then BD is a median. Segment BD is a median. So keep in mind too that I could draw a median from each vertex of the triangle to the appropriate opposite side, so we would have 3 medians per triangle. So go ahead and pause the video and write the converse of this definition, and then when you restart it, go ahead and check to make sure that you got it right. Alright, so here's our converse of the definition. If a segment is a median of a triangle, then it joins the vertex of the triangle, or joins a vertex. Let's switch that. A vertex of the triangle to the midpoint of the opposite side. So make sure you update your theorem sheets with this definition and its converse. Moving on to altitude. This is our second special segment of a triangle. If a segment is an altitude of a triangle, then it is drawn from a vertex of a triangle and is perpendicular to the opposite side. So key difference here, we're going to go from the opposite vertex perpendicular as opposed to from the opposite vertex to the midpoint. So again, since I have 3 vertices in a triangle, I can draw 3 altitudes, but I'm only going to draw one. So here's triangle ABC, and I'm going to drop down a segment so that it forms a right angle with the opposite side. We'll call that point D. So again, in this picture, BD is an altitude. Alright, so again, go ahead and pause the video and write in the converse, and then when you restart the video, the converse will be written in there so you can check it. Okay, so here we have the converse. If a segment is drawn from the vertex of a triangle and is perpendicular to the opposite side, then it is an altitude. So again, make sure you get this definition and its converse on your theorem sheet. These are going to be very important definitions, so make sure you learn these. So moving on to the first example, so these are our 2 topics, but we're talking about going beyond CPC/TC. So for this first example, I've got that QS bisects angle PQR. That's what I want to prove, and I know in order to prove this, so to prove this, we need, and I'm going to just label these 1 and 2, angle 1 congruent to angle 2. Okay, so in order to get this ray bisecting this angle, I'm going to need angle 1 and angle 2 congruent, and then we'll know the rays bisected it. So kind of thinking through the proof, in order to get 1 and 2 congruent, these look like they're corresponding parts of the top triangle and the bottom triangle. So if I can get the triangles congruent, then I can get 1 and 2 congruent. If I can get 1 and 2 congruent, that means that QS must have bisected this big angle. So let's go ahead and get that down into a proof. As always, if you want to pause the video and then restart it and check as you go, it's always important that you listen to the examples as I go through them, because I'll give you some important information, and also write down any questions that you have and make sure you ask me in class. So I've got that PQ is congruent to RQ, and I've got that PS is congruent to RS, and these are both given. And I'm going to go ahead and mark these on my diagram. So PQ, RQ, and then PS and RS. So I can see on my diagram I have two pair of sides congruent, so I either need a pair of angles or a pair of sides. I'm going to use this reflexive side going right down the middle because that's part of both triangles. So I've got QS congruent to QS, and again this is one of our exceptions, so I can say reflexive property. So here's a pair of sides, here's another pair of sides, and this is the third pair of sides. These are optional, and really in this proof we don't need them because there's only 3 steps to get to the triangles congruent. So now I've got triangle PQS is congruent to triangle RQS, and my reason is going to be side, 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 and the steps that I got all those parts from are 1, 2, and 3. If you don't put the numbers in, you're going to lose points on the quizzes and tests. So now that those triangles are congruent, I know that all the other corresponding parts are congruent, and angle 1 and angle 2 are corresponding parts, so they'll be congruent. And our reason is CP, CT, C, corresponding parts of congruent triangles are congruent. And now that I have 1 and 2 congruent, I know that means that ray QS must bisect angle PQR. And we're going to go back to the converse of our definition of bisect. If a ray divides an angle into two congruent angles, then it bisects the angle. Okay, so this definition is from a while ago, but everything in geometry is continually building on previous things, so you want to make sure that you're not forgetting about these things. Alright, so that's the first example. We've got 2 more examples. If you want to try and do these on your own and then restart the video, that's great. Otherwise, you can follow along as we go. So for the second example, I want to prove that QS is a median. So in order to prove that it's a median, I'm going to need to get PS and RQ congruent, and I'm going to get these congruent hopefully by proving that the top triangle and the bottom triangle are congruent. Then PS and RS will be corresponding parts. So I've got PQ congruent to RQ. It's given. And I've got angle PQS is congruent to angle RQS. That's also given. So let's mark these on the picture. PQ, RQ, PQS, this angle over here, and RQS. So again, just like the last problem, I can get this side congruent to itself. So I've got SQ congruent to SQ by the reflexive property. And that's all I need now to prove that triangle PQS is congruent to triangle RQS. So however you name the triangles, make sure you name them in a corresponding order. So since I named P first on the top triangle, the point that corresponds to that on the bottom triangle is R, so I'll name that first on the second triangle. So we go around in the same order, PQS and then RQS. And then for this one we have side angle side. Again, our steps that we use to prove it are 1, 2, and 3. And then once we have those congruent, I know that PS is going to be congruent to RS. Those are corresponding parts. So CP, CTC, corresponding parts of congruent triangles are congruent. And now that I have these 2 segments congruent, I know that QS must be a median. So QS is a median if a segment extends from the vertex of a triangle Now, I'm going to write sort of an alternate version. So you may want to keep this in mind because this is actually shortening our proof by a step. Otherwise, once we say that PS and RS are congruent, we would have to say that S is a midpoint. But the way I'm going to write this alternate definition, I won't need to do that. So if a segment extends from the vertex of a triangle and divides the opposite side into two congruent segments, then it is a median. Okay, so again, if you don't use this alternate version, if you put the word bisect in here, then up in your proof you're going to need bisect after step 5. So as always, if that's a little confusing to you and you want to ask me a question, make sure you write down your question so you can ask me later. Alright, so one more example. I'm going to go ahead and work out this example. So why don't you pause the video and work it out on your own as well. And then when you start the video again, I'll have the completed proof for you. So you can compare and check to see if you did it right and write down any questions you might have. Alright, so here's the completed proof. As you can see, we've got 10 steps here. So let me talk through the proof first and then I'll go ahead and show you the rest of it. So the way I got DB and EC are congruent is by getting these two thin triangles on the left and the right congruent, and then AB and AC are corresponding parts. And these triangles overlap, so it gets a little confusing. AD and AE are also corresponding parts. So if I subtract these two little pieces at the top from the whole big sides, then I'll get the pieces at the bottom that I want to prove congruent. So if we look at the two triangles, I've got this triangle over here, and I've got this triangle over here, and we're going to do more with overlapping triangles. And then the other interesting thing about this is that we have this angle at the top that they both share, angle A. That's a reflexive angle. So we're getting these two triangles congruent by angle side angle. We're using the altitudes to get perpendicular, the perpendicular to get right angles, the right angles congruent. So from the altitudes, I get these two steps. Okay, I get that CD is perpendicular to AB, and I get that BE is perpendicular to AC. And then from there, from these two steps, I get these right angles. Okay, so since these segments are perpendicular, I know I have these right angles, then I know these right angles are congruent, and that's one of the pairs of angles that I have. So I've got a pair of sides given, these are the little sides. I figured out the right angles are congruent, angle A is reflexive, and that's all I need to prove that the triangles are congruent. So once I get the triangles congruent, I get AB and AC, which are these whole big sides, AB and AC. Those are corresponding parts, CPCTC, and then I'm going to subtract the segments in step 2 from the segments in step 9 to get the segments in step 10. If congruent segments are subtracted from congruent segments, then the differences are congruent. So again, make sure you write down your questions and ask them. Feel free to review any part of this video that you think you might want to watch again, and we'll see you next time.